As with most problems, we want to start off by drawing a diagram of the situation. So right over here, this is a typical diagram of your double slit experiment where you have the separation distance between the openings right here, and you have your screen that shows the interference pattern. Now, these m's are simply your integer values, so it's just the difference between the wavelength between bright fringes in this case. And we'll denote that with a y sub n when we're talking about the distance between the bright fringes. Next, we need to go ahead and figure out if we're going to be using the constructive interference formula or the destructive interference formula. Now, the question states if the bright interference fringes on the screen are separated by 1.58 centimeters, what is the wavelength of the laser light? So that right there indicates we're going to need to use the constructive interference formula. Now, we have a really cool technique that we can do to simplify questions like this. Now, when this separation distance, so 1.58 centimeters, is much less than the separation distance between the slits and the screen, which is L right here, we were told that it's 5 meters. So 1.58 centimeters is very tiny compared to 5 meters. So what we can go ahead and do is we can alter the sine theta variable. And in this case, we can say it's almost equivalent to tangent theta. So take a look at this triangle right here. This is how we're going to find what tangent theta is. So as you can see right here, tangent theta, if we take where this cursor is to be the angle theta, then y sub m over L is tangent theta, so we'll make a quick substitution right here. Now we'll go ahead and rearrange the formula to solve for the wavelength, and now when we plug in our numbers, just make sure that you convert all of these centimeters and millimeters into standard units of meters. You'll find that you'll get a wavelength of 632 nanometers. And if you're curious what color this is in the visible light spectrum, it is the color red.